Hello, my name is Emmanuel and I am presenting Bitvote. So Bitvote is a multi-chain voting standard that has synchronized multi-chain states with all the logic and multi-chain blockchain read and write coordinated by Chainlink CRA workflows. So someone can create a campaign, someone can vote on existing campaigns, and someone can also register themselves as a voter into the system through the Chainlink workflows. So I'll be demonstrating the execution of the workflows using a hypothetical UI via HTTP triggers. So it has exactly three workflows. One is Bitvote, designed for enabling voting. So when someone votes, everything that the campaign that they voted against, their vote is registered across all the different chains. So the vote is synchronized across all the chains. And it enables an interoperable system for voting. So wherever someone is coming from, whether they're on Base or Arbitrum or Ethereum, particularly Sepolia, they can still vote and have their vote registered on all the chains. They can also create a campaign and then they can register themselves as a voter. So I'm going to start with creating a campaign and demonstrate how the workflow works. So what typically happens is that this campaign is going to be created on all the deployed system contracts on all these different chains. And every time someone votes on this specific campaign, their vote is registered on all those different chains. All this activity coordinated by the Chainlink CRE workflows that I designed for this application. So the workflow is called create campaign, and the payload that is going to mimic a request from an HTTP via HTTP from a front end or another backend server is right here. So all this information will be coming through the HTTP request from the end user. Perhaps if they wanted to register a campaign, maybe they wanted to register a presidential election, and this is the duration for which that election will be valid. So beyond this period, in terms of seconds, so beyond that period, that specific campaign will be invalid. And then the threshold entry point. So the voting system is based on the Bitvote standard. So that means the people that are going to vote must have accumulated a certain amount of time in terms of the weight that is required for every specific campaign for them to be able to vote. So if I execute this workflow, it is going to create those campaigns on all the three chains that I deploy the contracts on, and then we'll be able to see that it actually interacts with the keystone forwarders and then creates those specific campaigns on the different chains. So when it starts to create the campaigns on the different chains, it will display for me what chain is actively being written to. So in this case, we have Ethereum testnet Sepolia. And when it's complete, it should give me the transaction hash. Then I can check for the transaction hash on the Explorer, then see what it actually did. And exactly the same thing happens for all the other chains, and we can verify it on chain. So you can see this is the campaign information for the campaign that we're going to create, that is in the process of being created rather. And yeah, it is complete. So I can now check this on the, so this is the address that I used to interact with a mock key forwarder on Sepolia. And so I wrote a report, and through this report I created a campaign. I can check the internal transactions and see which contracts I was exactly interacting with. So yes, I called the report function. Then the key forwarder interacted with this contract F1D, which is a deployed contract on Sepolia from my configuration for that specific instance of the system. So there are also a few events that were emitted. One from the very function that processes the call data. Okay, so this is the workflow, and it's the workflow we just executed. You can also look at the contract and see where all this data is actually processed. So in this method process report, when I receive the report, I decode it into the specific different data types and variables, and then I can use them to create the campaign. So this is exactly the section of the code that we are executing. So yeah, that's one of the things that we could do with the workflow. We could also vote on campaigns that already exist and then register our own campaigns. It enables interoperable voting standards, where even if someone is voting with tokens on Base, their vote is still registered on all the other chains in where the system is deployed. So it does not restrict users from using the application, regardless of where they are, they can still have the service delivered across all the chains where the system is deployed. And all this is enabled through the Chainlink workflows, the CRE workflows that are deployed for this specific application.